statistics. Hey guys, in this session we are working on solving past exam questions associated with statistics.
Okay, so we are still busy with the topic of statistics. Now, in this session, I want us to complete this question. Okay, you'll recall that in our previous session, we just looked at how to determine the values of number one, the correlation coefficient, and then number two, the equation of the line of best fit. Okay, we did that for this situation, and then we found out that the correlation coefficient R is 0.95, if I'm not mistaken, and then the equation of the line of best fit is y is equal to 9.5 plus 0.91, okay, x. Okay, so this is the equation of the line of best fit. Now I want us to complete this question in this session, so let's get that done. Okay, so let's begin. It says that a mathematics teacher was curious to establish if her learners' math marks influenced, okay, so the math marks, if the math marks influence the physics marks. Okay, and then in the table below, the maths and physics marks of 15 learners in her class is given as percentages. Okay, so straight up we know that this is the x variable or the independent variable, the maths mark, and then the physics is the dependent variable or the y variable. Okay, and now they give us the scatter plot, and then we know that the scatter plot is just a visual representation which basically represents the relationship between the two variables. Okay, so we are representing the relationship between the maths marks, which is the x, and then the physics marks, which is the y. Now we can we can draw a line that best fits this data, right? Now we call that the line of best fit. Let's get it done. Okay, so the idea is to draw a line, a straight line through this data set such that it touches many points as possible. Okay, so let me try and demonstrate that. Let's see. Uh, this is not the pen that I'm looking for. Okay. Let's see. Mm, mm, yeah. Okay. Mm, no, that's not the line that I'm looking for. Let's try again. Mm, okay, that's much better. Okay, so the idea is to try and ensure that this line passes through as many points as possible. And then another tip is for for us to ensure that the points that are not touched by the line, okay, they are arranged in such a way that the amount of points that are above the line are approximately equal to the number of points that are below the line. What do I mean by this? We can see that the points that are not touching the line that are above the line is 1, 2, 3, and 4. And then the number of points that are not touching the line that are below the line, they are 4. 1, 2, 3, and 4. So based on this little principle, we can say that the we have approximated the right way, more or less. Okay. So this is the line of best fit. Okay. And then question 1.1 says that determine the equation of the least squares regression line. Now, I spoke about this terminology issue in our last session. I said that this is simply a fancy way of saying that the line of best fit, which is simply the line that we just drew. Okay, this line, the red line that we just drew. Okay, so they want the equation for this line. Now we have done this already in a previous session. We said that the equation of the line of best fit is given by this form. Say y is equal to a plus bx, and then we saw that the value of a is 0.9. Let me just check. 0, it's 9.5 actually. I don't know where I'm getting 0.9 from. So this is 9.5, and then the value of b is 0.91. Therefore, the equation of the line of best fit is y is equal to 9.5 plus 0.91x. Okay, so this is the answer for this question. So the answer is y is equal to 9.5 plus 0.91x. Now, in an exam or in a test situation, uh, what you do is you have to write down this step, okay, this one, that one, and the final one, okay, in order for you to get all the 3 marks. Okay, so you have to write the value of a separately, the value of b separately, and then at the end combine all of them as one equation to get the entire 3 marks. Okay, just remove the 8. And then the question 1.2, they say that we must draw the least squares regression line on the scatter plots provided. Now we have already done that. So this is what we did over here. Okay, that is done already. And then 1.3, they say that we must predict the physical sciences mark of a learner who achieved 69% for mathematics. Now, you will recall that when we were discussing all the concepts associated with statistics, I spoke about these 2 ideas. One, I said it's interpolation, and then the other one was extrapolation, whereby I said that we can take an x value that is not part of the data set. For example, the one that they've given us is 69. There's no 69 here. There is no 69 in this data set. As we can see, that 69 is not here. Okay, but then 69 is within the range of this data set. In other words, it is between the smallest one, which is 19, and the highest one, which is 85. 69 is between this data set or within this data set. So in this situation, you will agree with me that it is the process of interpolation. So what we do basically is very simple. We know that the max marks is x values, right? Okay, so they've given us the x value. They want us to get the physics mark, which is the y value. And great news is we have the equation. Okay, we have the equation. So what we'll do is we'll simply take the x value, plug it into the equation, and then we can get our y value. So let's get that done. So what we'll do for this question is we'll say that y is 9.5 plus 0.91, and then instead of us to put x, we'll put the value of the max mark, which is 69, and then we'll use our calculator to evaluate this. 9.5 plus 0.91, and then into 69, and then let's see what we get. We get 72.29%. Okay, 72.29%. So this is the physics mark for a student that achieved 69% in mathematics. Okay, so the answer is 72.29%. Okay, let's get rid of this. Okay, and then we can say that we can do 1.4. 1.4, they say that write down the correlation coefficient between the mathematics and the physics marks for the date. Now, we did this already in our previous session. We saw that R, or the correlation coefficient, is 0.95. Okay, 0 R is 0.95. Okay, and then they ask us to comment on the strength of the correlation. This is very important. Okay, they ask us to comment on the strength of the correlation between the maths mark and the physics mark. Okay, so based on the value of the correlation coefficient, what can we say about the strength of the relationship, or the strength of the correlation between the two variables, the math mark and the physics mark? Now, you will recall that I went through a series of these interpretations doing when we're doing all the theory related to this question, and we established that if the the correlation coefficient is between certain values, then that means this. Okay, if you are not sure what I'm talking about, please do yourself a favor and go back to the session whereby we were talking about the theory or all the concepts associated with statistics, because there we established that if the value of the correlation coefficient is this one, for example, then the relationship between the two variable is a very strong, not just very strong, but then it's a very strong positive relationship or positive correlation. Okay, correlation. So it's a very strong and positive correlation. This is our answer. And then 1.6, they ask us Uguti, what trend did the teacher observe between the results of the two subjects? What trend, okay, did the teacher observe between the results of the two subjects? Now we have to remember the main purpose of this experiment in the first place. The teacher wanted to see if there is any correlation whatsoever between a student's maths mark and their physics mark. Now we have established that there is a very strong and a very positive correlation. Now, the trend that the teacher observes, or the trend that we ourselves can observe, is that the higher the student's maths mark is, then that is what will happen to the physics mark as well. In other words, if a student scores a good mark in maths, then the student will most likely score a good mark in physics as well. Okay, so that will be our answer. We'll say that um, the higher a, a student's math mark is, the higher the higher his physics mark is his physics mark. Okay, so we can see that there is a very strong and positive correlation between a person's maths mark and the person's physics mark.
We've come to the end of our session. Please like and share our videos with your classmates, friends, and family members. Ensure that you follow us on all socials at XYZ Math Tutoring, and don't forget to subscribe to our YouTube channel. I have dropped the link to our YouTube channel on the comment section. Go check it out. Have a great day.